Till now, we have looked at fairly simple problems. It is problems like these that basically students think that they are very hard. So, therefore, I wish to explain that no problem, no matter how it looks in the first glance, is difficult. All you need to do is follow the same procedure that you have learned for simpler problems. That is what I used to say. I have learned that from my teacher that if the problem is simple, you can build your intuition, you can use your intuition. But when the problem gets difficult, it's the maths, is the procedure that is going to save us. So simpler problems must be used to learn the procedure and then apply the same procedure for difficult problems, and you can reach to the result because the intuition does not help. And in simpler problems, no matter how much of your intuition tells you to write the answer directly, no, always do all the problem, all the steps. So here, let us look at the problem for the circuit. Always read the question in detail. For the circuit and switches configuration as below, there are two switches. There are two switches. Fine, and the behavior is clearly shown. It is clear that this switch was initially here. At t equal to 0, it goes here and removes this link. And this switch was open. It does not close at t equal to 0. Rather, after the switch has moved from here to here, it closes 5 seconds after that. So this is a question of sequential switching. So initially, all the circuit was in steady state, and then this switching happened, and then some time passed. We don't know whether it achieved steady state or not because it depends on time constant. If 5 time constants would have passed, then this circuit would have again achieved steady state. But if 5 time constants have not passed, lesser time has passed, it would not be in steady state, and we need to solve the values for t is equal to 5 minus just before the switching. And then this occurred, and then the long time may have passed, and we need to come up with the expression for this current, and this current is through a short. There is nothing here. Okay, so this is very interesting. So let us look at the various times that we have to encounter. So just before the first switch got to action, what was the time? The time was t is equal to 0 minus. Now the circuit at this point was in steady state. Let's redraw all the circuit. Oh, don't forget that it is not only a capacitor here and a inductor here. We have an inductor here as well. So everything would be in steady state. So if everything would be in steady state, then the inductors, all the inductors would have converted to short circuits, and rest of everything would be there. Let us redraw everything. It may take some time. So this switch was here in this position. So this is what we had here, a capacitor that had been open circuited, a resistor here, it's still open, this a short, and then there was a switch which is still open, and then there is an inductor that would have shorted out, and then these things here 4 volt. I'm not going to write each and every value, but a few of those only that make difference. So before t is equal to 0, what was this voltage? This would be Vc at 0 minus. And what would be this current? This current would not be Ix it would be Ix at 0 minus. Although we may not be really interested in knowing its value at this time, because this is for a time that we are not interested in. We are interested in t greater than 0. So what is going to happen? We have a resistor, no current is flowing here. All this voltage is going to appear here. There will be some current here, but it does not matter. This inductor does not matter in this current. Why? Because at t equal to 0, the switch comes to this side. So this is left out. So it is not going to play any part in here. So this voltage, you can, I hope, very easily through my explanation, see that Vc 0 minus would be 9 volt fully charged, and this current, we should also take this along. IL at 0 minus would be 0 ampere. Why? Because this is an open, there is no current flowing here. So the energy storing elements, initial conditions have been found, their initial states has been found through this analysis. Now at t is equal to 0, the switch throws to this side, and what do we get at t is equal to 0 plus, or another way we can say between this time 0 to 5 second. In this interval, the circuit would be looking from this Ix point of view. We need to find the state of the circuit from this point of view. What we need to find. So we will have a capacitor here. It's not open now. Why? Because switching has just occurred. It may or may not be in steady state. We have a resistor here, and then the switch is still open. So let me just leave it out. So this Ixt, this is for a duration, so I am writing Ixt, and then this Vct would be the things of our interest: a capacitor of 2 farad and a 2.5 ohm resistor. So now you can fairly easily see that between this time interval, only this is the circuit that interests us. We can find Ixt based on this. Can you now see that the initial value of Ixt, that is Ix0 plus, would be, what would it be? We cannot say that IL0 minus is 0, or for that matter in this circuit, in this case, Ix at 0 minus is also 0. No current here, no current coming from here. This is open, this is open. Ix, initial value of Ix is 0. We cannot say Ix, just after switching the value of Ix would be 0 as well. We cannot say this. Why? Ix is not through an inductor. This is very, very important. Please pay close attention. So what will be Ix at 0 plus at a particular instant? Now this is also very interesting. So this was for this duration, this circuit, but at this instant that we are trying to find, how the circuit would be behaving. This capacitor would be behaving as a voltage source of how much volts? 9 volts. Here we are. This and this are same, and we are looking at that instant only. So what can you now tell about Ix at 0 plus? It is simply 9 divided by 2.5 ohm, 9 volts over 2.5 ohm, whatever that current is. So we have 9 over 2.5 ampere. I usually don't have a calculator, so I'm very lethargic to calculating actual calculations, simple ones. I hope that does not make me lose marks if you are the checker. So now this is the initial value, and this current totally depends on this thing. What will be the final value? So if this circuit is left to remain in this state for a long time, not up to 5 seconds. Suppose this is future, 5 seconds is yet to come, and we don't know what's going to happen. The circuit will start behaving as if it is going to stay in this form forever. So in this form, the final voltage of Ix would be, this would have opened up, and therefore if this is opened up, no current will be flowing in the circuits. So Ix infinity would be 0. So based on the general solution, Ixt would be 9 over 2.5 e raised power minus t over, and tau for this case would be RC, which is 2.5 into 2, which is 5 seconds. So we have this interval is just 1 tau, so it does not go to steady state. This is Ixt for this period. It is very important. So what would be the value of Ix just before 5 seconds? It would be 9 over 2.5 e raised power minus 5 over 5 or e raised power minus 1. So whatever that is, again, if I don't have a calculator to solve 9 over 2.5, I definitely don't have a calculator to solve this. And we cannot say, this is very important, we cannot say this is equal to Ix at 5 plus. Why? Because this current Ix is not through an inductor. It's the property of the inductor that it does not change its value uh, suddenly. Okay, so what is now going to happen in this interval, t from 5 seconds to plus infinity? So what are we going to get? We are going to get a capacitor that has still not opened up, and this resistor, this short is definitely going to stay, and now we have this come into play. Now what we are looking at, we are looking at two different circuits. This is very important. Most of the students cannot make sense of this.